In this video, we are going to study time series decomposition with classical method in R. As you can see at the bottom of the screen, this is an educational video only, and no professional advice is included within it. Okay, so let's go into RStudio. So the first step within the video is that we need to load the corresponding packages. Therefore, we comment this as step 1, packages. And for loading packages, we use library function and within it the name of the package. So for this video, we'll be using forecast for time series characteristics, and also with library function, we'll be using ggplot2 for the corresponding charts. To run these code lines, we select the code lines and then we can either click run or we can press Ctrl Enter on the keyboard, which is equivalent. Then we continue with step number 2, which is data. For data, we're going to create an object named mData or model data, which is equal to air passengers object. This air passengers object is located within our datasets package, which is already installed with R. And we want to visualize part of this data, and we do so by using the head function, and within it we include mData object. So to run these code lines, we go ahead, select them, and now we're going to press Ctrl Enter on the keyboard. And as we can see, this creates the mData object within the global environment as a time series of length of 144 observations. And right here within the console, we see part of this data being printed, specifically the first 6 observations from January to June of 1949. And this is monthly airline passenger numbers in thousands. If you want to read the full documentation on this data, you can go into the Help tab and search for the object name, which is air passengers, select it, and then you'll see the documentation below. As mentioned previously, we have monthly airline passenger numbers in thousands from 1949 to 1960. So now we're going to continue with ranges delimiting. And we're going to create 2 ranges, a training range for model fitting and a testing range for model forecasting. So let's begin with the training range. So we're going to create an object named tData, which is equal to, and here we'll be using window function and within it the following parameters, which are x equals to mData, comma, end equals to c 1958, comma 12. So the training range is going to be the first 10 years of data from 1949 to 1958. That's why we see that it's the end at 1958, month 12. And then we're going to create fData, which is the testing range. And again, we'll be using window function. And within it, we have parameters x equals to mData, comma, in this case, start equals to c 1959, comma 1. So in this case, the testing range is going to be the last 2 years of data, 1959 and 1960. That's why we see that the start is at 1959, month 1. In this video, we'll only be working within the training range. So to run these code lines, we go ahead, select them, and then we're going to press Ctrl Enter on the keyboard. And now we want to visualize this data within its corresponding chart. So we comment this as chart, and here we'll be using autoplot function, and within it we have the parameter object, which is equal to tData or training range data, and then we're going to add labs or labels, which are going to be y, that's the vertical axis label, and that's going to be air passengers, and x, which is the horizontal axis label, as year. So to run this code line, as it is a single code line, we select any part of it and we press Ctrl Enter on the keyboard. And right here within the plots tab, we can see the corresponding chart. So let's go ahead and zoom into it. So as mentioned previously, on the vertical axis, we have air passengers, on the horizontal 1 year, and then we have the solid black line, which is the training range data. So now that we have the data ready, we can continue with step number 3, which is time series decomposition. And for this, we are going to study the classical method. Therefore, we're going to create an object named TSDEC, which is the training range time series seasonal decomposition, which is equal to, and here we'll be using decompose function, and within it we have the following parameters, which are x equals to t data or training range data, comma, type equals to, and within quotations we have additive, comma, filter equals to null. So regarding these parameters, type additive, that's the additive seasonal component. And then we have the filter equals to null because we want a centered moving average. If you have any questions regarding this decompose function, you can again go into the help tab and search for the function name, or you can input right here within the console the question mark decompose without parentheses and press the enter key. And you can see the documentation right here within the help tab. Notice that we need to check whether additive or multiplicative classical seasonal decomposition by moving averages is needed within this training range time series seasonal decomposition. Also, notice that range is delimiting and this time series decomposition function parameters were only included as educational examples which can be modified according to your needs. And the following step is we want to visualize this within its corresponding chart. So again, we'll be using autoplot function, and within it we include the object TSDEC. And to run these code lines, we go ahead, select them, and we press Ctrl Enter on the keyboard. And again, within the plots tab, we'll see the charts. So let's go ahead and zoom into them. So here we have decomposition of additive time series. The first chart is the one with the training range data. Below we have the chart with the trend cycle component. Below we have the chart with the seasonal component. And last we have the chart with the remainder component from this time series decomposition with classical method. So we go ahead and close this chart here. And with this, we finish with the code file, so we can go ahead and save it. And with this, we also finish with this video. Thank you for watching.